going to have a look at inverse functions. Now, this continues a trend with functions where it's a more formal way of writing out something you've probably done before. And in this case, it's rearranging an equation. So, looking at question 1, we want the f of -1x. So again, it's got quite complicated notation, but all the -1 means if you find the inverse, the opposite of the function you're given. And for question 1, the function we're given is 10x minus 7. So how do we find the opposite of this function? Well, so a little trick is, firstly, we're going to turn the f of x into a y, and we're going to imagine that this is an equation we're going to rearrange, and we're going to make x the subject of the equation. So to make x subject, we want x on its own, x equals something, and x has got two things with it. It's got the plus 7, and it's got the multiply by 10. So the first step, reverse BIDMAS order is usually the easiest, so let's get rid of the plus 7 by taking 7 away from both sides. Now, we don't know what y is, so we can't take 7 away from y, so all we do is write y minus 7. So that's the left-hand side sorted out. On the right-hand side, we've got the 10x, we've done nothing to yet. And then positive 7, take away 7 is 0. That's why we chose take away 7, because it's got rid of it. Now, for the next step, we still want to make x be on its own. It's got a times 10 with it, so the opposite of that would be divide by 10. We divide by 10 on the right, we also need to divide by 10 on the left. Now, again, on the left, we can't actually divide y minus 7 by 10, so what we do is just write y minus 7, write a fraction symbol, and we write it over 10. On the right hand side, 10 lots of x divided by 10 will give us 1 lot of x. And again, that's why I chose it, just to get x on its own. Now, this isn't our final answer. Remember, we swapped f of x with y at the start to make it a little bit more understandable. And at the end, we've got to put the f of x back in. So our answer is going to read f of -1x. That's what we're trying to find. That's going to take the place of the x. So I'm just going to highlight where it's coming from to make it clear. Then, on the other side, we're going to swap the y for x. So it's not going to have y minus 7, we're going to have x minus 7, but it's still over 10. And again, I'm just going to highlight where I got that from. So what have I done? Well, you can see I swapped the sides around. So f of -1x is written first. Not a big deal, but that's how you'll see it written in the answers. And then you can see I swapped x for f of -1x, and I swapped y for x. And so what we have now is we have the inverse function of what we had in the question. And something to notice here when we're talking about inverse functions is that in our original function, f of x, we had 10x plus 7, so we're multiplying by 10 and adding 7 to x. In the inverse, with the x, we're taking away 7 and dividing by 10. So the multiplies become divides and the adds have become takeaways. So let's try this with question 2. Again, I'm going to imagine that f of x is going to be a y, and we're going to rearrange to make x the subject. Now again, the x is being multiplied, and this time it's being taken away from. Reverse BIDMAS order, take away 11 will be the first thing to do, so the opposite of taking away 11 would be adding 11 to both sides. So y plus 11, we can't do it, so we just write y plus 11 and leave it like that. We haven't touched the 2x yet. And then -11 plus 11 is 0, so we don't need to write anything down for that. For the next step, x is being multiplied by 2, so we're going to need to divide both sides by 2. Now again, on the left-hand side, we can't actually do it. We can't divide y plus 11 by 2, so we just write it as a fraction. On the right-hand side, 2x divided by 2 would be 1x. Now we've made x a subject, we have to now write it in our final answer format. So we want f to the -1x. That's what we're asked to find in the question. And we've changed the x into that. On the other side, we're going to change y into x. So we're not going to write y plus 11, we're going to write x plus 11. and it's still being divided by 2. Again, just highlighting where I've got that from. So I swapped the sides, I swapped x for f to the negative 1x, and I swapped y for x. Moving on to question 3. So again, swap f of x for a y, make it a little bit more understandable, a little bit more like changing the subject, because then we're going to make x be the subject. X being divided by 14, and it's having 11 added to it. So in reverse Bidmas order, we'll get rid of the plus 11 first. So we'll be taking away 11, doing the opposite. And that will give us y take away 11 equals x over 14. X is being divided by 14. The opposite of that will be multiplying by 14. Do that to both sides. And a little trick here is we could multiply both the y and the 11 by 14, but rather than bothering to do 11 multiplied by 14, what you can do is just write down the 14 and then put the y minus 11 in brackets, which means the same thing, but you haven't actually had to do the multiplication. And then x divided by 14 times 14, they'll cancel out, we'll be left with x. Now x is subject, we can write it in our final format. So we want f to negative 1x. So if we change the x into f of negative 1x, then we're going to take the 14y minus 11 in brackets. I'm just going to change the y into an x. So that'll give us 14x minus 11. Now, there's just one thing to be careful of. I have left that 14 outside the bracket, so I haven't actually multiplied by 14. Just read through the question once you've done it. If it says it wants the answer in a particular format, it might indicate it wants you to do the multiplication by 14. So just be aware of that when you write your final answer. Moving on to question 4. So again, we're going to be looking at this in terms of x's and y's. We want to get x on its own. It's been added 9 to and divided by 13. Now, normally we want to take away the 9, but that divide by 13 is touching the x and it's touching the 9. So the 9 is also being divided by 13. So when you've got a large fraction like this, it's easier to get rid of that first. So rather than dividing by 13, the opposite would be multiplying by 13. Do that to both sides. Y multiplied by 13 is 13y. And then when you multiply by the denominator of a fraction, you're just left with the numerator, x plus 9. Still trying to get x on its own, it's got a plus 9 with it, so we need to take away 9 now from both sides. And we can't take 9 away from 13y because we don't know what y is, so we just write 13y take away 9. On the right hand side, we've only got x left because 9 take away 9 is 0. Now we'll look at our final answer format. Again, taking the x, and what we've actually found is f to the negative 1x, the inverse function. And then taking the expression, 13y minus 9, we kind of invented that y being in there, so we're going to change it back to an x. So it'll be 13x minus 9. Now looking at question 5, again, we're going to work in terms of y. We want to make x be the subject. It's in a fraction. It's over 6. So the opposite of dividing by 6 is multiplying by 6 for the first step. Y multiplied by 6 is 6y. And then we're just left with the numerator of the fraction. Now, there's two things with the x being multiplied by 4 and it's being subtracted by 5. So work in reverse Bidmas order. Let's get rid of the minus 5 first by adding 5 to both sides. 6y plus 5 would be 6y plus 5. You can't actually get a numerical value out of it. We haven't touched the 4x yet, and negative 5 plus 5 is 0. X is now being multiplied by 4, nothing else, so we need to divide by 4. Do that to both sides. As usual, over on the left, we can't get a numerical value for it, so it's going to write 6y plus 5 as a fraction over 4, remembering that divides and fractions are the same thing. And then 4 lots of x divided by 4 is 1x. So looking at our final answer, we take the x, and we've actually found the inverse of x, and then we're going to take our expression, and I'm just going to put x back in. So it's not going to be 6y, it's 6x plus 5 all over 4. Now, if you take a look back over all these answers, you'll notice that the function and the inverse have all got the same numbers, but we've just swapped the symbols around. So, for example, in question 5, we've got to divide by 6 in our question. In our answer, we've got to multiply by 6, we've got 6x. In the question, we've got to take away 5. In the answer, we've got a plus 5. And in the question, we've got to multiply by 4. And in the answer, we've got to divide by 4. The problem is it's not as easy as just swapping those symbols around, because you can see we've all got different kind of variations of where you have the fractions involved, and all the answers look completely different. So it's worth going through this process just to make sure that you get your divide and your multiplies in the right place. Moving on to the medium questions, these work in the same way as the easy questions. We've just got some squares and roots involved, so we've got some more complicated bits of maths happening. So we're going to swap f of x for y, just for our working out. We're going to make x the subject, and in question 1, I can see it's been divided by 5. That division is touching everything, so we need to get rid of that first. So we'll multiply both sides by 5. Y multiplied by 5 is 5y. And then we've just got the numerator, the fraction left on the other side. So we've got the x plus 6. And then what the brackets and the root symbol mean is the root is touching everything. Now, still wanting x on its own, it's been added to by 6 and it's been rooted. Now, given the root sign colours the x and the 6, it works similar to fractions where you can't get rid of the plus 6 yet because it's being contained by the root. So we need to get rid of the root first. And the opposite of rooting is squaring. So we're going to square both sides. So 5y squared, what we can do is just write down 5y, pop it in brackets, and pop the squared sign on the outside, just to show that both of those numbers are being squared. And then squares and roots cancel out, so we're just left with the x plus 6 on the right hand side. Then we want to get rid of the plus 6 by taking 6 away from both sides. So we're going to get 5y all squared, take away 6, is equal to x. So now we can write down our final answer. So the x is going to become our f to the negative 1x, and our expression, we're just going to swap y for x. So we're going to have 5x all squared, take away 6. Now, there is an alternative answer here. Maybe you're being asked to write it in a certain format, and you can actually square 5x. And what you could write instead is when you have the squared sign outside brackets, it means everything inside the brackets is being squared. So the 5 is being squared to 25, and the x is also being squared. So you get 25x squared, and it's still taking away 6. However, it can be okay to leave things in brackets. It just keeps the answer looking a little simpler. Moving on to question 2. So again, f of x, we'll replace it with a y for now. Our expression's been divided by 11, and the divide by 11 touches absolutely everything. So that's the first thing to get rid of. And the opposite of divide by 11 is multiply by 11. Remember to do it to both sides. That will give you 11y. And it will give us x minus 2, all of it being rooted. Now, given that root symbol touches everything, much like the divide did, we're going to have to get rid of that next. So we are going to square both sides. So the 11y is going to be squared. and we're just left with x minus 2 on the other side. Last thing to do is add on 2 to get x on its own, and that'll give us 11y all squared plus 2 is equal to x. So now we can construct our final answer. So the x is going to give us the f to the minus 1x. The expression on the other side, we're just going to swap y out for x. So 11x all squared plus 2. And again, we could actually get an alternate answer, and we could actually square what's inside the brackets. So you do 11 squared is 121, and you'd have x squared. So you have 121x squared plus 2. Moving on to question 3. So again, let's work with a y. Now, with this question, you'll see that the root symbol is containing absolutely everything. Now, one way of showing this is how I've done it here with the brackets. Another way of showing it is that rather than using brackets, let's get rid of those, you'll see the root symbol just covering the entire expression. So you see it written as it just was with the brackets if you're using a computer, and you'll see it with the root symbol covering everything like I've just drawn now if you've got some kind of visual way to show the diagram. So because everything's contained by the root symbol, we're going to square first. So that means the y is being squared, which will give us y squared. And on the other side, the root symbol's now gone, so we've got x plus 5 all over 4. Now, again, we've got a situation where symbols covering every single term. The x and the plus 5 are being divided by 4, so we'll have to get rid of that next by multiplying both sides by 4. And y squared multiplied by 4 would be 4y squared. On the other side, we've lost the denominator of the fraction. Now we need to take 5 away from both sides to get x on its own. And that's going to give us 4y. Take away 5 is equal to x. So now we can write out our final answer. We'll swap the sides and have f the negative 1x. And then with the other side, we take the expression and we're just going to swap y for x. So that'll be equal to 4x squared take away 5. Now for question 4, so again, make it be in terms of y. We're going to try and make x be on its own. And again, we've got a situation, one of the symbols is containing all the others. And the squared symbol, because it's got the brackets around the x and the plus 7, we're squaring the x and we're squaring the plus 7. So what we need to do the opposite squaring, which is square root to both sides. This will give us the square root of y equals, and then come to cancel out the squared sign, don't need the brackets anymore. So we've got x plus 7. Then we need to get the x on its own, so let's take away 7 to get rid of the plus 7. Do that to both sides, and that will give us a square root of y, take away 7, is equal to x. So we've made x the subject, so now what we need to do is write our final answer. So let's swap the sides. The x is going to give us the f to the minus 1x. And then our expression, the root of y minus 7, we'll swap the y out for an x, and that's going to give us the root of x minus 7. So swapping the y, it's just that we're just using different variables, so we don't get confused having two different lots of x's, one for the regular function and one for the inverse function. but at the end we can swap it back. Now moving on to question 5. So again, swapping f of x for a y, just for now, so we don't get confused with two different sets of x. We want to get x on its own as being contained by a squared symbol, so we're going to root both sides. This will give us the square root of y is equal to x minus 3. Take 3 away from both sides, and that'll give us the square root of y, take away 3, is equal to x. Now x is the subject. We'll convert it back to the notation we had at the start. So the x to the f to the minus 1x. We've got our expression, so we'll swap back to using x's rather than y's. So we're going to have the square root of x minus 3. Importantly, square root, just note that, for example, in question 3, the square root sign contained the entire question, so the entire fraction had the square root sign above it. Now, in this answer, square root is only over the x. It does not go over the minus 3. So just be really, really careful how large you make your square root symbols and what actually they are covering. Moving on to the hard questions. Now, these are going to work a similar kind of way, but now we've got much more complicated fractions. So, looking at question 1, as usual, f of x, I'll change it into a y, just for ease of working out. And now we've got a fraction, we've got a numerator, and we've got a denominator. So what we need to do here is we're going to multiply by the denominator. And the denominator, we're multiplying by all of it. So the 9x plus 3. We're multiplying by every single part of it. And we do that on the right. We've also got to do that on the left. So we're going to multiply by 9x plus 3 on both sides. What that gives us is, if we're multiplying y by 9x plus 3, we can just write y, and then we can write 9x plus 3 in a bracket on the left-hand side. Then on the right-hand side, we're just going to have the numerator of the old fraction. Now, with the workout, it's a little bit messy, so I'm not going to write multiply by 9x plus 3 on both sides. Best way to do it, to indicate what I'm doing, is to highlight the bottom of the fraction and show that it's being moved to the other side. Now, we've got x's on both sides, so our first job is going to be collecting all the x's on one side. And since one of the x's is in brackets, so I have to get it out of those brackets. So we're going to multiply both terms inside the bracket by y. So we have the 9x is going to multiply by y to give us 9xy. The 3 is going to be multiplied by y to give us 3y, and the other side stays the same. So now I'm going to move the 4x over to be with the 9xy. And to do that, we are going to take 4x away from both sides. Now, we can't take 4x directly away from 9xy because the y is complicating things. So we're going to keep the 9xy separate for now. We're going to take the 4x away from it. And we've still got the 3y on that side as well. And on the other side, the 4x is gone now. So we've only got the 5. Now, we still have two lots of x, and we're going to try and combine them together. And we can't do takeaway because a y is involved. So what we're going to do is we're going to factorize to get the x out of there. So we're going to take the x, and we're going to divide 9xy by x to give us 9y. We're going to divide 4x by x to give us just the 4. And now we've got the x on its own. And we've got the plus 3y there, and we've got the 5 on the other side. Now, we're still not done because while we've combined the x's, there's still a few things with it. So firstly, probably going to be easier to get rid of the plus 3y. So we'll take 3y away from both sides. That'll give us our x, still stuck to the bracket. 3y take away 3y is 0, it's gone, that's how we did it. And then the 5 has 3y taken away from it. Now the last step, we're going to get rid of that bracket. I'm just going to highlight it in pink. Now that bracket is being multiplied by the x. A letter and a bracket next to each other is a multiplication. So we want to divide both sides by 9y minus 4. Now, just like right at the start, you remember we did that, the working out was a little bit messy. So I'm just going to do a little arrow and just going to move this over to the other side. And rather than being a multiply, it's now going to be a divide. That's going to give us x equals 5 minus 3y, but now the 9y minus 4 we move to the other side is now dividing all of that. Now, that being done, we're now free to write our final answer as usual. So it's going to be f of minus 1x. We found the inverse function of x. Everything's going to be the same, but when we come to y, we'll swap it back into an x using the same variables we had in the original question. So we have 9x and minus 4. And there's our answer. And you'll notice there's quite a lot of working out for questions like this. So they are significantly harder and there's a lot more involved. So let's try that method again for question 2. So we're going to work with a y as usual. And since we have a complicated fraction, I'm going to take the denominator and I'm going to move it over to the other side. Remembering that at the moment it's a division because it's a denominator. When we move it over, it'll be a multiplication. That'll give us y and 5x plus 7, multiplying it. And on the other side, we've got the numerator of the old fraction. Now, again, we want to get all the x's onto one side. So we're going to take 4x away from both sides to get all the x's together on one side of the equation. So we haven't touched the bracket yet. We've taken the 4x away. There's nothing else on that side. And then we've got the negative 2 is now on its own on the right-hand side. We're going to have to expand the brackets because we still have the x's apart from each other, and we need to free the x from the bracket. So we're times 5x by y to get 5xy. We're times 7 by y to get 7y. We've done nothing with the minus 4x and nothing with the other side. Now we've got two sets of y's. And I realise I've made a mistake here because when I'm factorising, I want to factorise for x, not y. The y's are together, and I want the x's together. And what's happened is, in the first question, I expanded the brackets, then I moved the x over. This time, I've moved the x over, then I've expanded the brackets. So the x's are not next to each other. Now, it's the same maths, so we're still going to be able to do this. And so what I'm going to do is just highlight what I'm factorising. They're not next to each other, but that's fine. We've got the 5xy and the negative 4x. These are the two terms with a common factor x. The 7y doesn't have a common factor of x, so I'm going to ignore that. So that's not included in my factorisation. So both of those terms have got an x in, let's put that outside the brackets. The 5xy, we're going to divide by x, which will just give us 5y left. The negative 4x, divide that by x, which just leaves us with negative 4. Then the plus 7y I've ignored, can go on the end. We've done nothing with that. And then we've still got the minus 2 on the right-hand side. Now we want to get x on its own. There's two things to get rid of. Firstly, we'll get rid of the plus 7y by taking 7y away from both sides. So we've not touched the bracket yet. The 7y is gone. And the negative 2, we're taking 7y away from it. The next thing we need to get rid of next to the x is the bracket. So we're going to take all of the bracket, divide by it to move it to the other side. So then when we write this out, we're going to have x on its own. The numerator, what's on the right hand side, the -2 minus 7y. And then the denominator, since that bracket was a multiplication on the right hand side, on the left hand side, on the right hand side, it's going to be a division and be a denominator of the fraction. All that's left to do now is write it in the proper format. So we've got f minus 1x, and that's going to be equal to -2 take away 7y all over 5y take away 4. Now, the last thing I do, there's quite a lot of working out here, so I'm just going to make it very, very clear what my final answers are. So I'm just going to put a green box around both of my answers, just so there's no mistaking what I'm actually intending the examiner to mark. Moving on to question 3, and again working in terms of y. We're going to take the denominator of our expression and start off going to move it over to the other side of the equation. Remembering that if it's a divide on the right, we multiply on the left. So we're going to have y multiplied by 7x minus 1 is equal to, and we've just got the numerator left on the other side. Now, when I collect all the x terms together, and one of them is trapped inside a bracket, so let's get it out of the bracket. So there's a y on the outside, let's multiply both terms by y. 7x multiplied by y is 7xy, and -1 multiplied by y is -y. Other side hasn't changed. Now let's collect up the x's, so let's take x away from both sides to move the x over. We can't take it away from 7xy because the y is involved, but we'll write it next to it. We've still got the -y, and then on the other side, x take away x is 0, that's why we did it, it's gone. So we've just got the -3. Now the x's are next to each other, we can't factorise, so we're going to take x out of those expressions. We're going to take x out of 7xy, we'll just have 7y. And if we take x out of -x, then we're just going to have it's -1x, so we've just got -1 left. We've still got the -y, and we've still got the -3. Now we can start moving things away from the x. Now the x's are collected together. Let's add y to both sides. So we've done nothing to the bracket yet. The y is now gone, and we've got -3 plus y on the other side. Finally, you want to get rid of the bracket. Now this is now a multiplication. So if we move this bracket away to the other side, then we're going to have the opposite operation, and it's going to be a division, forming a fraction. So let's write that out. We'd have x equals the -3 plus y stays where it is, but now it's going to be in a fraction with the 7y minus 1. The final step now is to turn it into the final form. So x is going to become f to the -1x, and then the fraction, we're just going to swap y's with x's. We've got -3 plus x all over 7x minus 1. And then again, with so much working out, it's worth making it really clear what the answer is and doing something like putting a box around it. Another thing we can do with the answer is the numerator is -3 plus x. Now, if we swap the -3 and the plus x around, what we can do is, you don't need to write the plus sign on the x that's at the start. And so the other way around has one less character, which makes it a little bit simpler to read. Now, an odd thing you'll notice here is that the inverse function is the same as the original function. Now, this can happen sometimes. It's a coincidence, though, it's not a rule. You don't always get the same answer twice, as we saw with question 1 and question 2. Things like that might happen if you have repeat numbers. For example, we've got 1x on the numerator and -1 on the denominator. So those numbers are kind of swapped around, but because of the same number, you can't see that that's happened. Looking next at question 4, so again, we'll work in terms of y. We'll take the denominator. Now that all that is being divided, so we move over to the other side, it will now be being multiplied. So that will give us y equal y bracket 4x minus 2, with the numerator on the other side left alone. So let's expand the bracket first. So y times 4x will give us 4xy, and y times -2 will give us -2y. The left-hand side hasn't changed. I now dealt with the bracket, so I want to try and get all the x's on one side. So let's add 3x to both sides. And that'll give us the 4xy. I'm going to write the 3x next to it, which will help me factorise later. I've got the -2y still. And then on the left-hand side, a -3x and a +3x gives 0, which is why I chose it. But we've still got the +9. So now we need to factorise to get x as a single term. So we're going to take x out. We take x out of 4xy, we'll just have 4y. And we take x out of 3x, we're just going to have 3. The -2y is going to stay as it is, as will the 9. Now we want to move the -2y away. We want x on its own. So we're going to add 2y to both sides. We haven't done anything with the bracket yet. The -2y has gone. It's moved over to the other side, so we'll have 9 plus 2y. The last step of our rearrangement is going to be taking the bracket, which remember is a multiplication, and we're going to move it over to the other side, so it'll be changing back into a division. I'll leave x equals, got the 9 plus 2y, and now it's going to be divided by the 4y plus 3. Now I'll write down our final answer. So x is now going to be f of x, or f of x to the -1. And we're going to swap y's with x's. So it's going to equal 9 plus 2x all over 4x plus 3. Remember to make it really clear what your answer is. So I've used colour coding, I'll put a box around it. And then remember, you can swap around the numbers on the numerator and the denominator, either adds and subtracts. So we could write 2x plus 9 on the top if we wanted to. There's no reason to do that at the moment, but sometimes the exam paper might ask you to write it in a certain format. Now, finishing off with question 5. So we're going to work in terms of y. Again, we're going to take the denominator and we're going to move it over. So that's going to give us the y. The denominator was being divided as the bottom of the fraction, so now it's going to be multiplied on the other side. Put it in a bracket, and the numerator will stay as it is. Let's expand those brackets, so multiplying -5x by y will give us -5xy, and then multiplying -2 by y will give us -2y. The right hand side will stay the same. Let's move the x's all over to one side. So let's add 2x to both sides. That's going to give us negative 5xy. We'll write the brand new 2x right next to it to help us factorise next. Negative 2y, and it's all equal to negative 2. Let's factorise. We'll take x out. If we take x out of negative 5xy, we'll just have negative 5y. If we take x out of 2x, we're going to have just 2. Then we've got the negative 2y, and it's still equal to negative 2. We can move the 2y away from the x. We want the x on its own. So move as many things away from it as possible. The brackets stay the same. The negative 2y is now become 0, it's gone. And on the other side, we've now got negative 2 plus 2y. The last step is going to be to take that bracket, and again, that bracket is going to be moved over to the other side. And where it's a multiplication on the left, it's going to become a division on the right. So let's write it out. X will be equal to, so we've got the numerator on the right, and the denominator is going to be those numbers we're moving over. Negative 5y plus 2. So now we can write out our final answer. The x on its own, so f to the minus 1x, the inverse function is equal to, and all we're going to do is swap the y's for x's. So we're going to have negative 2 plus 2x all over negative 5x plus 2. Now again, we can simplify this slightly by swapping these around and putting the negative a second, because again, we don't need to write the plus sign if it's the first term. So we'll swap plus 2x with minus 2. So the plus 2x goes first, we can write the minus 2 second. And on the bottom, the minus 5x and the plus 2 we can swap around. So I'll write the plus 2 first, and then the minus 5x. Now, for the most part, this is an unnecessary step. It does simplify it slightly by just getting rid of the plus symbols. And again, just watch out for exam papers saying, can you write it in exactly this format, where you might have to do a bit of rearranging like that at the end. And there's our final answer.
Ouch! This is why in some videos I have unexplained scratches.